Welcome back, Transatlantic AI hackers. This is Jay Burris and Eric Kolkaj. I'm your OpenVINO Academic Program Manager from the Network and Edge Group at Intel. As a reminder, we're bringing 3 exciting collaborative AI-capable technologies to you: OpenVINO, the Intel Developer Cloud, and Luxonis's OakD-like device powered by Intel Movidius VPUs. Each accepted participant will receive a Luxonis OakD-like device. But let's get practical and actionable. Let's talk about the GitHub resources available to you today. Let's start this discussion with the topic of pre-trained models and public models available at the Intel Open Model Zoo. They're free to use. You can take advantage of the model downloader to quickly access these models. We have over 100 public models that were developed out in the industry, publicly available on things such as classification, segmentation, object detection, and more. And we have over 100 pre-trained models from Intel as well for a variety of use cases, including text detection, recognition and spotting, action recognition, image retrieval, and many more. Visit github.com/OpenVINO Toolkit/open_model_zoo. And that's what we'll do right now. So here I've accessed the OpenVINO Toolkit GitHub location at github.com/OpenVINO Toolkit. You'll see the repository for the OpenVINO Toolkit. You'll see the repository for the OpenVINO Notebooks. We'll come back to this. And the repository for the Open Model Zoo. In the Open Model Zoo, if you scroll down, there's a bit of narrative that describes the repository itself, what you'll find, and how easy it is to use. In here, we have Intel pre-trained models and public pre-trained models, as well as the model downloader and other automation tools available to you, and a link to demos, as well as the accuracy checker. Let's explore the Intel pre-trained models for a moment. The pre-trained models are classified and categorized like object detection models. You scroll down further and further, you'll see object recognition models, re-identification models, segmentation models, and much, much more. Let's explore one model, for example, human pose estimation. This is something you can actually use with the Luxonis device. Each of these models will provide you some specifications about the model, the required inputs for the model, and in the first training I explained that models are designed and have specific input requirements to them. So they'll often have a specific shape, the batch size, the number of channels such as RGB, typically 3, the image height, and the image width. Going back to the public pre-trained models, you'll also find models categorized, classification models. Further down, you'll see segmentation models. You'll see instance segmentation models, 3D semantic segmentation models, object detection models, and so forth. And you can see how the models, they've been trained on a particular AI framework like TensorFlow or PyTorch. These models are they're all coming from open source sources, typically developed by researchers and academia. So if we were to go in and explore a particular model, anyone will do. You'll find something very similar. I'll just go to this anti-spoof model here. You'll find the narrative about this particular model. You can also access the original repository and the research behind the model itself. You can see the specifications of the model, the accuracy, as well as the expected inputs for the model, the original model and a converted model. At the OpenVINO Toolkit GitHub repository, we also have Jupyter Notebook tutorials. They're fantastic because they're executable code surrounded by written narrative. A number of examples, you could start out with the Hello World. It's a basic introduction to OpenVINO with a Python API. It shows you how to do inference with a MobileNet v3 image classification model. We also have a Jupyter Notebook instructing you how to use the OpenVINO API, as well as Jupyter Notebooks on how to do the IR conversion, or the intermediate representation conversion, from a trained model on TensorFlow or PyTorch to the OpenVINO IR format. We have a Jupyter Notebook on TensorFlow training, and we have a Jupyter Notebook on the model tools, such as downloading the model from the Open Model Zoo, converting it to OpenVINO's IR format, how to show model information, how to do asynchronous benchmark the model on CPU, integrated GPU, and both combined. And there's a number of other ones. It's not just 8, there's actually over 60 Jupyter Notebook tutorials that you can try out for things like monodepth, where you want to take an image, in this case the image of a black dog, and apply monocular depth estimation to this. Another one is background removal, with this image of a dog, and you can take out the background and replace it. In this case, we've replaced the background with our black dog on the Great Wall of China. So let's go and try an OpenVINO Jupyter Notebook. We're back at our GitHub OpenVINO Toolkit repository at github.com/OpenVINO Toolkit. Let's go to the OpenVINO Notebooks. Now, scrolling down, you'll see some narrative about what the OpenVINO Notebooks are about. It's a collection of ready-to-run Jupyter Notebooks for learning and experimenting with the OpenVINO Toolkit. And there's an easy installation guide here. So first, let's visit that. Upon visiting it, you'll see the guides for all of these different OSs. So let's go to Windows, because I likely bet all of you are going to be using Windows. But if you're not, you can try out one of the other OSs. Now with Windows, it's 9 easy steps. You install Python, you install Git, then you install Microsoft's Visual C++ redistributable. Then you'll install the notebooks through these steps below. You'll create a virtual environment. So start after you've done your installs of the 3 dependencies above. Open up a command prompt. And start executing these instructions here. So I'm going to go through them one by one. So first, I'm setting up and creating the virtual environment. It takes just a moment, it's already done. Now I'm going to activate the environment, and I'm just copy and pasting these. The environment is activated. Now I'm going to clone the GitHub. I've already cloned it, so it gives me an error. Fatal destination path already exists. But when you do it, it'll create a whole list of directories at your location. I'm users JMBurris, that's my directory structure. Now you'll change into the directory. And now you can see I'm in the directory here. If I do this, I see files within this folder. And there's a folder here called Notebooks. Next, you're going to install the packages. And because I had already installed it, it does give me a warning. It was already satisfied, but it is going through the process of uninstalling and reinstalling the Git through Python. Now it's important to do this next step because you're setting up the requirements for pip install and the OpenVINO Toolkit. You'll see it'll take a few minutes to finish, and now it's done. Now to launch a Jupyter Notebook, it's very easy. This is an example. You start out with the command Jupyter space notebook slash, and you identify the Jupyter notebook that you want to use. So we'll start this one just as an example. You can see another browser window opened, and I have my Jupyter notebook all set up. This one is an example of that monodepth estimation. And how to run these is really easy. You can step through, run, 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 or you can certainly run all at the same time if you want, well, sequentially. Now this one's running, it's processing the frames, and it's telling me it's 30, 50, 60, and the inference frames per second. And now it's produced the video. So it's the video of the black dog, and it's now produced it in the monodepth format. And it's just a very short clip. You can see it's 4 seconds long. So let's scroll all the way back up to the top. So you've seen how to run it, but you can see in the Jupyter Notebook, it'll walk you through all the tutorial steps and explain what's going on. First, you're setting up your imports and loading your libraries, standard libraries for like time and OpenCV, libraries for matplotlib, and so forth. Here you're defining device as CPU. You could actually define the device as GPU if you have an integrated GPU on your laptop. It's defining your functions. It's loading the model. Then it's loading, it's doing the load, resize, and reshaping of the input image. And in this case, we're using an image of Coco the black dog, Coco_bike in this first part. We're doing the inference on the image. And so this is just an example of an image of Coco, our black dog, on a bike, and now monodepth applied to it. And we plotted it out and printed it out on screen. Now below, you can see monodepth in video. So here were our video settings, loading the video file, doing the inference on the video, and creating the monodepth video, which you saw already, the really short 4-second clip. Now, these Jupyter Notebooks are going to be installed on wherever you decide to install them, but typically it's going to be users and your username, or it may just be your straight C directory. You have to define where you're going to install it, but it'll install this OpenVINO Notebooks directory. And in here, you'll have a number of folders and these additional like make files and so forth. But in the Notebooks folder, you have all of the Jupyter Notebooks, over 60 of them, available and installed for use. The one we used was 201 Vision Monodepth. And so the models are in here. You can see the .bin and the .xml file. The output is where the video, the inference video that was produced, has been stored from your Jupyter Notebook. And if you go back in this Notebooks directory, down near the bottom, you'll see data. And in data, you'll find a number of pre-supplied images. Here we have our image of Coco on the bike. And let's go back here. Video file will also supply Coco walking, and that was the video that we applied the monodepth to as well. Let's also get you started with the Hello World Jupyter Notebook. So we're back at the OpenVINO Notebooks, so github.com/OpenVINO Toolkit/OpenVINO_notebooks. And let's go into the Notebooks folder and click on 001 Hello World. Now, the actual Jupyter Notebook file is this .ipynb file. And that's going to be important to know where this location is so that you can start it. Now, coming back to our instructions on setting up and installing, you don't have to go through all the steps every time you open up a command prompt window. But you will need to set up your environment again, or activate the environment. So starting from step 6, activate the environment. At this stage, because you've already cloned the Git, you don't need to do that again. So just go into the OpenVINO_notebooks directory. You don't need to do a python-m pip install again, but you will want to do the requirements. And now we're going to change which Jupyter Notebook we're going to open. So we're going to start with part of this instruction, and then we're going to extend it to the location of our Hello World Jupyter Notebook. So I'm going to start the 001 Hello World. And the full command is Jupyter notebook / the directory it's in and the ipynb file. Now we have the Hello World Jupyter Notebook opened. So this is a basic tutorial. It's using a pre-trained MobileNet v3 model. You could follow this link to learn more about the model. It's from the Open Model Zoo. It is trained on TensorFlow. And what we're doing is we're importing standard libraries that are needed, as well as the OpenVINO runtime. We're instantiating the core. We're going to read the model, so the .xml file, and we provide you with that in the Jupyter Notebook. We're going to set the device to CPU and set the output layer. Now, you can actually have some fun with this. So what we supply you with is an image of Coco the dog. But what I've done is I've added some other examples that I comment out here. We resize the image to be 224 by 224 because that's the required input size that the model is trained for, and the model specifications tell you that. We'll set the input shape and plot the image as well. I previously ran this Jupyter Notebook on an image of a cat. I'll rerun it again in a second, but after the section here with loading the image, we do the inference on the image and the output layer. And then we also are using a classifications label file here called imagenet_2012.txt. This model is trained on over 1,000 different objects, and they're specified in this imagenet_2012.txt so that you can translate what the model does and read from the image and output what it says. In this case, when I previously ran it, it said this was a Persian cat. But let's rerun it. Now, the first thing I probably want to do, just to be sure, is it's a good thing to restart and clear all output. And you can tell it's ready to go. It's a circle with an empty hole in the middle of it. When it's a solid circle, it's running. So now I'm going to run all. And I had uncommented the image of Coco the black dog, and we supply you that when you download it. So we have our image of Coco the black dog, plotted out, and it is telling us that that is a flat-coded retriever. And it's getting that information from this imagenet_2012.txt file. So if I go back to the notebooks folder, and I go back to data, and I go to datasets, and I go to ImageNet, you'll see this file. I'm going to open it up and show you. So you can see there's a particular number here, identifier for the model, and then it corresponds to a label, the classification. Let's see if I can actually search for retriever. And so this is what that image produced, was the classification for this. Now if I go back to my model and I were to uncomment out something else and comment out the original Cocoa, but first you would need to upload your own models. So you could do that by going back to your data file and to images, to image here, and I have uploaded a bunch of different images. It'll come with a number of these, but not all of these, because I added bird and car and cat and so forth. You'll get this one, but you could upload your own. And so I uploaded this image. I'm going to do it on car, and then we'll see how it runs. I'm going to restart and clear all output. Now it retains the coding that I changed, the uncommenting and recommenting. And I'm going to run all. Here's my image of the car. Now it says warplane, military plane. Models aren't always that accurate. It depends on how they were trained, and it depends on how large the data set was that they trained it on. Now perhaps this model was trained, it's a public model, it was trained on, say, some images of aircraft for some reason, and it's misinterpreting that it's a military plane. I've also uploaded other images, for example, so I'm going to do it on this train image. So I'm going to restart, clear my output, and I'm going to run all. See, I have this image of this red train, and the inference tells me it's an electric locomotive. That's pretty accurate. I could also try it on the bird. And I have my image of a blue jay, and you can see it says J. As a reminder, when you're ready to get started, number 1, try the Intel Developer Cloud for the Edge. Number 2, try out our OpenVINO Jupyter Notebooks on GitHub, which I just showed you. And number 3, explore Luxonis's depth AI resources, their documentation, their GitHub repository, and their Discord community. We'll be back later for more training videos. Again, we look forward to your creative solutions. Thanks from Intel, Luxonis, and all of our partners at the Transatlantic AI Hackathon.